Welcome to Deep Dive episode 3, where we dive deep into past paper questions. Today we have MCQ 11th question to 15th question of 2020 O-level science paper. So the 11th question, which statement is always true about the magnitude of displacement of a certain object? The magnitude means the amount, how big it is, right? So displacement is the shortest distance between two positions in space. When we're talking about the shortest distance between 2 points, it's always a straight line. The distance and displacement is two different things. Distance is the amount of things, space you traveled, and displacement is the shortest line between those two positions, like the position you started and the point you ended, those 2 points. So it is always indicated with a direction. Displacement always has a direction. Okay, remember that. Displacement has a magnitude and a direction. It makes it a vector. Do you remember vectors? Vectors are things that has the magnitude and a direction. So displacement is one of them. So the magnitude of displacement is always either equal or less than the distance moved. It is equal when the distance and the distance you traveled is in a straight line from point A to B. You can see in this picture how distance and displacements differs. Okay, so the answer is going to be 4. It's either equal or less than the distance moved. Displacement is equal or less than the distance moved. Next question. 12th. The electronic configurations of the atoms of two elements X and Y are 281 and 287 respectively. Of the following statements about the pair of those elements, which statement is false? Remember, we're asking about what false is. Okay. So in electronic configurations in 281, like that, the sum of these numbers 281 represents the number of electrons in an element. This electronic configuration, how electrons are in an atom. So amount of the numbers, so 281, so 11, that means the amount of electrons in that particular element. The number of electrons are equal to the number of protons in a neutral atom. That is a fact. Always number of electrons are equal to the number of protons in a neutral atom. Okay, a neutral one, not a charged one. And the atomic number is the amount of protons in an atom. It's also another fact. Atomic number is the amount of protons in an atom. So if we know the amount of electrons in a neutral atom, we can know what that element is, what that atom is, based on the atomic number. If you remember the first 20 elements in a periodic table, I think it's really important to remember the first 20, because if we write the first 20 in the how we see here, you can get at least 15 marks in the paper just by knowing this, because it's very useful. Like you can write how the valence numbers, you can get valence numbers, you can write formulas, things like that. So we can easily find the X and Y by summing the electronic configuration. X has 11 electrons and Y has 17 electrons. So we count hydrogen, helium, lithium, barium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium. That's the 11th element, sodium. And the Y is 17th element, which is chlorine. So we go back to the question. First, located in the same period in the periodic table. What is a period in a periodic table? It's the horizontal line, like lithium, barium, boron, carbon, nitrogen, oxygen, fluorine, neon. That's a period, horizontal. And group is vertical, like hydrogen, lithium, sodium, potassium. It's a group. We have 8 groups and 4 periods in our syllabus. So second, located. So tell me, sodium and chlorine. Is it located in the same period? It is located in the same period. It's the third period, sodium and chlorine. The second option, located in the same group in the periodic table. Group is what is vertical. Is sodium and chlorine in the same group? No, sodium is in the first group, chlorine is in the 7th group. Then we have chemically combined forming ionic bonds. When it comes to sodium and chlorine, if you remember, sodium and chlorine makes sodium chloride, which is salt, which is an ionic bond. I'll tell you a little further fact. Uh, this is not in your syllabus, you don't have to remember this. When the electric negativity is different, the difference of the electric negativity in two elements is more than 3.7, those two elements bond ionic bonds. Okay. So sodium and chlorine make ionic bonds. Fourth one, combine and form the compound with the chemical formula XY. Remember, sodium chloride is NaCl, not Na2Cl. It's NaCl. So four option is also correct. So 1, 3, 4 are correct. The fourth one is the second one. So the answer is 2. 13th question. What is the number of O2 molecules contained in 64 grams of oxygen gas? And we have the relative atomic mass given as 16. Firstly, let's define some numbers we see here. The 16 is the relative atomic mass of a single oxygen atom. Remember, a single oxygen atom. We are talking about O2, which is a molecule, not an atom. It's a molecule, O2. And 6.022 to 10 23rd power, this number is Avogadro constant, which means the amount of atoms in a sample of a certain element that is same weight in grams as its relative atomic mass. So what it means is, if we get, the relative atomic mass, right? From, let's get water, H2O, two hydrogen atoms and one oxygen atom, right? In O2, H2O. Hydrogen is 1, relative atomic mass of hydrogen is 1, and in oxygen is 16, right? 2 1s, 16, 18. So H2O's relative molecular mass is 18. So if we get 18 grams of water, so that's like a sip of water, right? Like 2 tablespoons. So 18 grams of water, that's like a sip of water. And the amount of water molecules, H2O molecules in that sample of 18 grams is 6.022 to 10's 23rd power. That's the amount of water molecules in the 18-gram sample we just took. That's the Avogadro constant. It's same thing with everything. If you get glucose, the C6H12O6, and it is 180 grams, not 80 grams, 180 is the relative molar mass of glucose, and if you get 180 grams of glucose, that has the same amount of glucose molecules as the Avogadro constant. That's what's amazing about Avogadro constant. We also call this the mole, this unit. It's also the SI unit we use to measure substance. Okay. What is Avogadro constant? It is the amount of atoms in a sample of certain element that is the same weight in grams as its relative atomic mass, or molar mass if we are talking about a molecule. In the question, we have 64 grams of O2 gas. 2 oxygen atoms are present, so the relative molar mass is 32, because we are talking about oxygen gas. So that means if we get 32 grams of O2 gas, there will be 1 mole of substance, or 6.022 times 23 molecules of O2. We have 64 grams, right? So 32, 64, that's 2. Which means the correct answer is 2, which is 2 by 6.022 by 10 to 20 power. So answer is 2. I hope you understand that. If you don't understand anything here, if you have having trouble, please comment down below. I will explain it. Because we have like a time limit, right? Because I couldn't get them channel wide. So I can't upload more than 15 minutes per video. Anyways, 14th question. W, X, Y, Z are 4 elements consecutively placed in the periodic table with atomic numbers below 20. So these are things we know, elements we know. The graph indicates how their first ionization energy, I1, varies against the atomic number. Which group is the periodic table is Y place, in which group is Y placed. Okay, we can see W, then we have a huge downfall, and we have X and little up, Y, little down, Z. Okay, let's talk about what first ionization energy is. First ionization energy of an element is the minimum energy that should be supplied to an atom in the gaseous state to remove an electron to form a unipositive gaseous ion. That means if you have sodium gas, we remove an electron from that sodium atom, and it becomes sodium plus, and an electron goes away. You have to remember these two lines, okay? This definition. They might ask it in the paper, second paper. Anyways, so what this is, I'll show you a picture. Look at the sodium and the chlorine ones we have, okay? So sodium has one electron in its valence shell, the outer shell, just one. In chlorine, it has 7. So in ionization energy, they are trying to remove an electron, right? Then pull an electron. Every atom tries to stay stable by getting either 8 shells in the outer shell and becoming noble gases, right? That's what every atom tries to do. Try to be stable, try to settle down in one way or another. So when you try to pull an electron, we have to keep in mind what kind of atom we are trying to pull it from. From sodium, in order to be stable, what sodium has to do? Just get rid of one electron, and it has 8 electrons in its valence shell. It becomes stable, right? So sodium is very likely to give a electron. So the first ionization energy is very low in sodium. And let's see chlorine, it has 7, right? It just needs one more to become stable and become a noble gas, become noble. And does it want to give one? When they want to take one and they become noble, would they like to give one? They already have, so they need 2 more. No. So we have to put a lot of energy to remove an electron from chlorine. So elements with 1 electron in its valence shell, outer shell, is the most with ones with the lowest IE, except for hydrogen, because hydrogen only has 1. It doesn't want to give the 1 it has. And the highest can be seen in the noble gas elements due to them having field valence shells, because they are already noble, they are neutral, they don't want to give anything at all. So they give huge. Their fight is very huge, so it's really hard. So a drastic drop in electric ionization energy, like showing W and X in this graph, means W is a noble gas, because in our 20 elements, the highest one's ionization is in the 8th group, lowest in the 1st group. So there's a huge gap between two. It's safe to assume that the highest one is a noble gas, 8th group, then the next one is in the 1st group. So by W being in the 8th group, X becomes in the 1st group. So we are asking what Y is, so it becomes the 2nd group. Okay. Okay, we have hurry up. The substance acting as the main component providing energy for the function of human body are lipids and carbohydrates, because lipids have 9 calories per gram and carbohydrate has 4 calories per gram, and carbohydrates is easy to digest, and lipids that mean fat, right? It is really calorie dense, like things like nuts or butter. There's a lot of calories in them. So they are the main provision of energy. We can read in the other 4 because we are running out of time. Protein, vitamin, read it from here. So that's it for today. Next time it will be from question number 16 to 20. Revise these, and if you like the video, like the video. If you have any questions, comment, and don't forget to subscribe.